In this video, I'll define what we mean by the greatest common divisor of two integers a and b. And we will give an extremely efficient algorithm, the Euclidean algorithm, for actually finding d. Much more efficient than factorising the two integers a and b and then just looking for the common factors. And finally, we'll discuss the extended Euclidean algorithm, which allows us to express the greatest common divisor as a sum or difference of multiples of a and b. And this in particular is going to be very important in showing in the next subsection that prime factorizations are unique. So the greatest common divisor of two integers a and b is simply the largest positive integer, which divides both of them. And we need to assume that a and b are not both 0, because if a and b was 0, then every integer would divide them. So at least one of them is required not to be 0. And then we write d is equal to GCD of a and b. So let's look at some examples. The greatest common divisor of 6 and 3 is 3, because 3 divides 6 and it divides itself. The greatest common divisor of 18 and 12, well, 6 is the largest integer, which divides both of them. The greatest common divisor of 4 and 10, of minus 4 and minus 10, of 4 and minus 10, and minus 4 and 10 is 2. Because it's clear that the greatest common divisor of 4 and 10 is 2, and the divisors of 4, the integer divisors of 4 and of minus 4 are the same, and the integer divisors of 10 and minus 10 are the same. So the general principle is that to find the greatest common divisor of two integers a and b, we really only need to consider the cases where a and b are both positive. And finally, you may elsewhere have seen the greatest common divisor being called the highest common factor. We'll say that two integers a and b are relatively prime if their greatest common divisor is 1. In other words, if they have no factors in common. So for example, 5 and 12 have no factors in common, so they're relatively prime. Likewise, 6 and 25 have no factors in common. They have no common divisor other than 1, so they are also relatively prime. And finally, if you have a prime p, another number a, and p does not divide a, then the greatest common divisor of a and p must be 1. In other words, a and p are relatively prime. That's clear, because what could divide both a and p? Well, the only number which divides p, apart from 1, is p itself. And on the other hand, p does not divide a, therefore the greatest common divisor is 1.